In this video, I'll show you how to build an end-to-end data science project. In this case, we're going to use the Titanic project, and getting the data is fairly simple. You just go on to Kaggle and you download it from there. But bear in mind, this is actually the most difficult and important part of any data science project, finding the data. In this case, it's as simple as downloading it, but in most cases, it's not. Once we have the data, here we already have it split in test and train. So if you don't know already, when you train a data set, you split the data in two. You get a 70 or 80% chunk and use it to train the model. And the rest, you use it to evaluate if the model is good enough on records that it hasn't seen yet. So on new records, basically. Once we have the data, in this case, we just import it and we create a data frame with it. And the first thing we do is we just look around. We explore the data. We understand what it is and what it means, if it's interesting, if it's useful. And one of the first things that you can do is find the null values. If there are no values, they need to be removed. And in this case, we see that age has 177 nulls, cabin has 687, and embarked has 2. So what we can do is find out how important this stuff is. So for example, cabin, 687 out of 891 are missing. So even if we tried to reconstruct this column, it wouldn't make sense. So what we do is we drop it. On the other hand, age is actually very useful, and we're going to fill the age, and the null values are going to take on the mean value for this column. And so now, if we check the null values, we only have 2 in embarked, and we're just going to get rid of those rows. And now, if we check, we don't have any missing values anymore, and that's good. Okay, so the next thing we do is we deal with columns that don't have numeric values. So as you can see here, we have name, which is not numeric, it's a string, and the same goes for sex and ticket and embarked. So all of these are not numbers, and a machine learning model cannot really interpret them. So we either need to get rid of them, or we need to find a way to transform these into something that is numeric and is valuable. So in the context of survived passengers, the name is not important. You know, if I know that your name is Alan or Montvilla or Graham or Johnston, it doesn't really give me information about whether you might or might not survive. And so this column, we're gonna get rid of it. And the same goes for passenger ID, actually, because it doesn't really have any predicting power. And the same will go for ticket and embarked. And so we're going to get rid of these columns. Sex, on the other hand, is a string, but the predictive power of it is very, very important, because women are the first to get saved, right? So we need to transform this column and take it from a string to a Boolean. So here we mapped the column and we gave 1 to males and 0 to females. And so now the data looks like this. We get 1 for males and 0 for females. And now what we have is only numbers. Now bear in mind, this is a very quick way to do so. Usually you should spend more time on investigating data. But if we check now, we can see the correlations there are between all of these columns and the survived column, which is actually what we're trying to predict for. And as you can see, there is a strong correlation with sex. There is somewhat of a correlation with passenger class. There is a very low correlation with age, actually, which is actually ironic because children are also saved earlier. So maybe that is not as important. I don't know. Also, these two columns have very low correlation, whereas fair has some more correlation. I think it might be a little bit skewed because children pay less, but I don't know. So probably it would be a good idea to also get rid of these two columns and investigate why age doesn't have that much of a correlation. I believe it should, and so because of that, we're going to keep it. Now, the next process, once we have our data clean and ready, is that of splitting it into features and targets. In this case, the target is survived, because that's what we're trying to predict. And all of the rest of the columns are our features. And so we split the data this way. So we have X, which is basically all of the data without the predicted class, and Y, which is the class that we're trying to predict. And now actually it's very simple to create a model once you have the data and it's been organized in the correct ways, because what we can do is basically import from sklearn this random forest classifier. We create an instance for it, and then we fit. That's it. It actually is much simpler than you might think. And now we have a classifier. Now, the next thing we do is we use the test data to see how good this model is. So I brought in this test.csv data. It needs to go through the same kind of processing that you have for your training data, because it's required to be in the same shape. And these are our predictions. Now, a way to evaluate predictions that is very nice is a confusion matrix. And we're going to first create that, and then I'll explain to you what it means. So this is the confusion matrix. This is the code to make it. It's very simple once again. And basically what it shows us is all of the records that have been predicted correctly and all of the records that have been predicted incorrectly. So as you can see, this diagonal right here has the correct predictions on it, whereas this one has the wrong predictions on it. So this model is kind of good, because out of 400 something, it missed 70-ish. So it has a kind of good accuracy, about 70%. So that is nice. It can be improved, obviously, in the ways that I told previously, with a more rigorous data exploration, with a more attent data transformation. But this is actually all you need to build a model. It's then easy to save it in a pickle file, and now you have your model.